Hello friends, welcome to the today's session. Today's session is how we could able to implement weak relationship or existency dependency or total participation in relational model. We all know that ER model is integrated with relational model. The very crucial point is that how weak relationship is implemented in relational model. So we know there are two kinds of relationships. Strong relationship that can be established simply using primary key and foreign key. But what about weak relationship? What is the ideology to represent the weak relationship in relational model? How does it happen? We are going to learn in this session using the concept of constraints. In this topic, mainly we focus on to primary key, composite primary key, unique key, composite unique key, and foreign key. So if you observe, the relationship can be established between one table to other table, that is possible with the primary key and foreign key concept. So let us learn how you could able to implement weak relationship in relational model. Before that, we start with our anthem, Crack Gate Computer Science with us, top educators, quality content, great learning experience. Let's crack Gate CSE. Crack Gate and ESE with India's largest learning platform, none other than Unacademy. Myself is Srinivasarao IS, having 17 years of GATE experience in the subjects of database, computer networks, and operating system, with a good certifications of the same like DB and system admin. Throughout my journey of GATE, I taught in many premium academies, including of MEDICE and others too, with a high success rate. Take the subscription of an academy and get the live and recorded lectures, and you can get clear your doubts with the faculty. There are two kinds of subscriptions, 12 months and 24 months. Use my referral code to get the 10% off and get benefit of them. Now friends, let's crack GATE CSC, subscribe to YouTube channel and use my referral code. So this is a schedule of upcoming classes which are running on YouTube and also running on special classes. Okay friends, now let us start what is the concept of entity integrity. If you look at why we are learning, especially I said about four important constraints, that is a primary key, foreign key, and unique key and foreign key. You can establish the relationship with the primary key as well as unique key, as well as composite primary key and composite unique key. So how come you establish a relationship? The relationship implementation is the two varieties as we know, strong relationship and weak relationship. Strong relationship, how to implement, what is the advantage, and weak relationship, how to implement and what are its drawbacks, we will learn in this lecture. So we know the concept of the primary key here, if you observe, it's nothing but it is going to say that nulls are restricted as well as duplicates are restricted. Now you observe what about in a unique key, we say that nulls are allowed in that, but it is a common between that and this is no duplicates. What about composite primary key? Same concept, no nulls, here also no duplicates. So what about composite unique key? So nulls are allowed, but we are going to say that duplicates are not allowed. So why we are calling it as a composite key means whenever I am saying that key is a composite, you consider that the key is defined on multiple columns. So the key is defined on multiple columns. So whenever a key is defined on multiple columns, then it is the concept of a composite key. So therefore, the composite key is talking in such a way. And now friends, so we are going to start our lecture with how you could able to implement the relationship concept. Remaining I'm not going to touch because we already learned in the earlier lecture. So now you observe carefully. There are the very important constraints which are mainly deals with the referential integrity where we need to focus much in this only. These are very important constraints as far as any kind of examination. That is foreign key constraint. This is also called as sometimes references constraint. The other name of foreign key is nothing but references. Now you observe there are other few options on this foreign key. That is, you can use these are the three options with the foreign key, especially with on delete concept, and you can use the following three constraints options using on update concept. Along with that, there is another very important concept that is called cascade constraint. Now friends, what is the main role of foreign key constraint and how the following options can be implemented? We will see it. These are all extension to your foreign key. Extension to foreign key you cannot use on your own. It should be used or they should be used only with foreign key only. Now you observe what is the concept of foreign key. Let us understand. When I am saying a foreign key is nothing but it is one of the constraints which try to put relationship between primary key as well as unique keys. And this primary key can be either you can go for simple primary key or you can go for composite primary key. Now here also the unique key comes under into two varieties. Either you can go for a simple or you can go for composite. Therefore, your relationship can be established with the help of a foreign key in any of the following cases like primary key or unique key. Okay friends. So what is the main and important thing of foreign key is that in this nulls are allowed as well as duplicates also allowed. So both are possible in this foreign key concept. So let us see why the necessity of the foreign key. We will check it out. There is a course instance and there is a student instance. Now the sum rows are here with the sum columns like course number and course name. I'm talking about 1. Oracle is the course name. I'm talking about 2. Java is the course name. Here some students are joined. So student number S1 and S2 and S3. And I am having another column called S name that is called XYZ. We have two questions here. What are the two questions? If I am asking you find courses, then you could able to get the data. That data is available in course table, so you can get it. Just to use the course table, you will get the answer for this. If I am asking find a number of students, now I can get alone without depending on any table. Simply I need a student table. But what is our third question? The third question is find the number of students who joined in different courses. Who joined in the courses. Now we are in a trouble to get this information. Therefore, what is the requirement? There is an association between this table to this table is required. This association we are calling it as in the form of a relationship. So relationship is nothing but association among the given tables. So when you have the relationship between, then I can able to share the data of students with your courses. Now what is going to happen? When I am saying find a number of students who are joined for different courses, then I am using course table as well as I am using student table. So by using a relationship, you could able to get the information. If relationship is not there, then what will happen? Let us check our goal. What is our goal? If no relationship, if no relationship between course and student table, then what is going to happen, friends? There may be a chance of the very important drawback that is called cross product. So what is the meaning of the cross product? All the rows of your course will be mapped with all the rows of with your student instance. Therefore, as per as previous example concerned, here two tuples are there, here three tuples are there, then we got almost all 2 into 3, that is equal to 6 tuples we are going to get. So this is the main problem when you don't have the concept of relationship. Now, because of these 6 rows, you can understand that there are some chances of what? Duplicity of the same row. That means S1 will repeat with all the courses, S1 will repeat with the Oracle ones, and S1 will repeat with the other course like, please observe, the student 1 is for Oracle and student 1 is for Java. Therefore, what is going to happen? Every student is going to come twice as per as this. So this is the concept. We understand that duplication of data. So that's why in order to avoid this cross product, there is an important terminology called association. The association is called as a relationship which is to be established between two or more tables using the concept of what? Primary key and foreign key. So when you have the primary key and foreign key, then you will have the concept of the relationship. So how come this happen and what are the types of relationships are there? Let us check. Now we have the concept as usually. I'm taking the course instance here and course ID, and here I have course name. Now you observe, friends, I'm making this is as my primary key. So I'm saying there are two courses are available. One is Oracle, the other one is Java, like this. So I'm taking one more table called a student, which consists of student number and student name. Now what I'm going to do, I'm going to use this primary key here. So you will get a C number column which is going to act as a foreign key here because it is referencing to your scores column. So you got CNO here. Therefore, what is going to happen? Now you see that student 1 is joined for course 1 and his name is X. Student 2 he joined for course 2, his name is something Y. Therefore, you observe, friends, you are going to get non-duplicity of data. Please understand. You are going to get non-duplicity of data because of the relationship. This is the important point. Because of the relationship. And what else relationship is also going to provide? That's very, very important. What is use of relationship? What is the use of relationship, also called as association? The first use, we guess there is a concept of what? Sharing of data. This is the first one. And the second one, what is the advantage? This advantage is the concept of what? Integrity. What is integrity? For example, I am saying there is a department instance and there is an employee instance. I have department number here which consists of 10 and 20 and 30 and designated as what? Primary key. Observe friends. In employee, I have employee number and I am maintaining a department number. E1 joined for 30 and E2 joined for example 40, and employee 3 joined in 50, employee 4 is joined in 60. And you imagine, I don't have relationship between employee and department. Please observe. I am not maintaining any relationship between this and this. You eliminate simply. So when you don't have the relationship, what is going to happen? It is the concept of what? You are not following the integrity rules. What is the integrity? There is no 40 department with you and 50 department with you and 60 department with you, but you are trying to assign the employees into those departments. This is the big problem with out having any concept of relationship. That's why what do we need? There is a requirement of what? Relationship such that I am taking this department number here. Therefore, you cannot give 40 here and 50 here, 60 here. Because every value of your foreign key is supposed to be subset or equivalent to your primary key value. So, these are all invalid because it is maintaining two kinds of integrities that we already learned: addition integrity and deletion integrity. Therefore, friends, addition means first whatever data you are inserting in child, that must be the subset of master. A deletion means first you clear the child first, then followed by master. So the advantage, what is the advantage of the relationship? Any interviewer ask you, you can say these two important things. One is the sharing of data I could get, and the other one integrity, such that don't enter the values foolishly. So every value of your child is supposed to be subset or equivalent to your master instance. So this is the advantage of your relationship. Now we learned from the previous lectures, that is the ER model, there are two kinds of relationships we observed. One relationship, strong relationship we observed. So we have types of relationship. How I am implementing in relational model, observe carefully. There are two types of relationships. One is a strong relationship. What is the meaning of the strong relationship? When you are asking about the relationship is nothing but, observe friends, all of you, there is a need of concept called, I am telling you that your primary key is being derived into some other table as a foreign key. Bus. What is the relationship? Simple answer. Relationship is nothing but primary key of one table is being used as a child key in a some other instance. This is only the definition of the relationship. There are two varieties of relationships we know. One is strong, the other one is weak. So this is very important in real-time implementation. So how the strong relationship is been implemented? Strong relationship is been implemented simply primary key versus a foreign key. Otherwise, you can say that unique key versus foreign key. Foreign key can be established not only on the primary key, foreign key can also be established on unique key also. So now let us refer a strong relationship in the next slide. When you talk about the strong relationship, you observe friends, there is supplier instance which consists of supplier number and supplier name, and item instance. I am saying that item number and item name and item rate and quantity that is supplied by other guy. So these are the columns I am maintaining in item instance. Now you observe friends, supplier 1 by name ABC Traders and supplier 2 by name XYZ Traders. Now you see item 1, it's like A and rate is something like 500 and the quantity I want 3. So which is supplied this item 1? There is a requirement of what? Sharing of this information now. By adding this information in this instance, then what is going to happen? See now. Now this item is being supplied by some supplier like S1. Now S2, there is other guy who supplied the item to, the item name is a B, its rate is 100 and he supplied 5 items. Now using this, I'm saying that this is the relationship to us. So when you have the relationship to us, this is called as a primary key as we guess, and this is going to represent as a foreign key in this case. So I can say that this is the strong relationship. What is the advantage? Now let us see advantage. Advantage is that the first advantage is you are having the concept of addition integrity. What is addition integrity? You say that whenever you are entering some value in child, first the value is supposed to be entered in master first. And what is other advantage here is that deletion integrity. First you delete, then you delete from your master instance. This we know. So these two advantages are with your strong relationship. Now I'm talking about weak relationship now. So when you are having weak relationship, what is the problem and what is the advantage? So the advantage here is that the same story, it is going to allow addition integrity such that master and followed by child. But what are its drawbacks? The drawback is only one. What is that? There is a violation to your deletion integrity. So what is the violation? That your deletion integrity is such that child must be followed by master, but there is a violation. This can be broken. How this violation can be implemented in your real-time relational model. So our target in today's lecture, how you could able to do deletion integrity violation. There are 3 rules to break your deletion integrity violation. So violation to deletion integrity. So what is the meaning of violation to deletion integrity? Nothing but point number 1, we can delete tuples from master without deleting child. Therefore, what is going to happen? Whatever you delete from master instance, that automatically is going to be affected to child instance. So whatever deleted from master, then it is affected to child. Then it is affected to child. So how you could able to do this violation? You can do with 2 important things. One is on delete and the other one cascade constraints. So using these 2 options, you can able to break a deletion integrity. One is on delete, the other one cascading. So you can use cascading also in order to perform that master can be deleted without deleting your child instance. So how this on deletion can be done and cascading can be done, we will see now. So when I am talking about a weak relationship, you need to think about 2 important things. One is a primary key, also called as, you can also implement using unique key, versus you have to use a relationship with the help of foreign key, plus you have to use this option. What is that? On delete. So the other side, we have on update also. You can use this in order to break your integrity rules. So what the on deletion? This is going to be fired at the deletion time. And what is on update? This is going to be fired at the time of modifying the data. So that means these two are executed. These 2 options are executed only whenever deletion and updation deletion and updation is done. You can type which instance, child instance or master instance. Please observe friends, these two options are executed only whenever there is a deletion and updation is happening in master instance. So this is a very important thing. So if you do this, if you do any kind of deletion and updation in master instance, and automatically that will be affected to your child instance. So how this can be implemented? Let me do this. I'm saying between course and student, I want to have, this is your weak relationship. Please observe, this is your weak relationship between your course and student. So I'm taking this relationship and it is a totally participated. So when it is a totally participated, we understand that this is your weak entity, this is your weak relationship. So how you could able to implement in relational model? Please observe, there is a course number here, there is a student number is here. Now I'm saying student number is your partial key. How could this to be implemented in relational model? So just by adding a concept called create a table only. So I'm creating now create a table course. All of you please observe carefully. The column name is a CNO, and I am saying a number data type, and I am saying that this is the primary key. Observe friends, all of you carefully observe and close it, semicolon. Now here what happened? The first table course is created for you. Now we want to create the student. So we are having student table. The next page, I am saying create a table student, and there is a student number, and this is a number here, and I'm trying to get the relationship because I created a student number here which is a partial key now to me. Now I'm going to merge this, so I'm merging this weak relationship into many side. As student is our many, then your merging is supposed to be into many side only. Therefore, this course number primary key will come into other side as a foreign key. Therefore, what is going to happen friends? SNO number, leave it. Now I am taking the course number into here. So CNO number, I am saying it is a what? Foreign key. Observe carefully. When I am saying foreign key, and you need to tell that you are referencing to which table. So references to which table? Course table. To which column? Course number column. Clear friends? If you leave like this, foreign key to your C number, references, course and C number, if you leave like this, it is a strong relationship. It's not the weak relationship. Please understand. If I leave this table is telling you that you have established strong relationship, not the weak relationship. Because foreign key is there and here is the common. But what is our ideal is nothing but we want to see that I need to represent weak relationship. So therefore friends, how to do the implementation of weak relationship? Now let us see. Now I say create a table, this time student, and I'm having student number. Number is the data type, and I am taking course number. Number is the data type. I'm saying foreign key. observe carefully, to C number, and I am saying references to master table, that is a course table. What is the column? C and O. Now you need to extend this. What is this? On delete cascade, or you can also say that other one, on update cascade. So here, what is the meaning of this? The meaning of this cascading is nothing but whatever you do in master, that reflects automatically into child instance. Now we made successful weak entity relationship. Now this relationship is weak entity relationship. The previous one, whichever I specified without on delete, without on update, it is called a strong relationship. The advantage of strong relationship I already shared. What is that? No violation for add and no violation for delete. But if you look at create a table student with weak relationship, I can do two violations. One violation on delete, one violation on update, which is similar to addition but not exactly. But we will see it how there is a violation to updation also. Now using this, we will go for a small example. So this is how you could able to implement in real time in relational model just by taking this particular option, foreign key with on delete cascade and foreign key with on update cascade. Now you observe, friends, what is on delete specialty? On delete has three specialties. One is a cascade. What is a cascade? If a master deleted, we know this. If a master tuple deleted, then child tuples will be deleted. Then child's deleted. Then the second special with on delete is set null. So what is this set null? If a master tuple is deleted, then child is set to null. Then child tuple set to null. And if you look at the third one is no action. So what is the meaning of no action is if a master tuple is deleted, then no result. If master tuple is deleted, then a no action in child. So these are the three important specialist operations with your on delete. How they will be? Let us see with a well-known example. The example is course here and student here. So I am talking about now course number. We designated this is the primary key and student number. I am taking this primary key here as a foreign key. Now what will happen? You got a new column by name C number. Now you see the data C1, C2 and C3. I have student number 1, student number 2, student number 3 and the course is given C1 and C1 and C1. Now my question is delete from course. Is it possible to delete? So how many rows are deleted? How many rows deleted? You can chat with me in the comment. How many rows deleted? Please understand. How many rows deleted? So when we are having a situation like this, there are 3 rows here and 3 rows here. Now the query is given like this, delete from course. Then how many rows deleted from course? So how many rows deleted from course? So we know that from course, how many rows are deleted, friends? You're all guessing. Please respond from chat. You're all guessing that how many rows are deleted from course and how many rows are deleted from student. So you're giving a reply, wonderful reply. What is that? 3 here. And how many rows from student are deleted? 3 here, but it is wrong, and it is wrong. Why it is wrong? Because you please observe carefully. You please observe carefully. C2 cannot be deleted. C3 cannot be deleted. Is it possible to delete C2 and C3? Please observe carefully. I have rows for C1, and I have rows for C1, and I have rows for C1, no rows for C2, and no rows for C3. Therefore, C2, C3 you can happily delete it. But it is going to give you an error for C1. What is that? You cannot delete any rows from your child table because already child rows are available with C1. Therefore, when I am saying delete from course, then you are going to get that course is deleted with 2 rows and student is going to delete with how many rows? 0 rows. Please observe, friends. Course is delete course because it is not on delete cascade. You observe it is what? Only what? Foreign key. It's not on delete cascade I specified. Observe the diagram carefully. It is the primary key. It is a what? Foreign key. What type of relationship it is? Please observe. It is the primary key. It is the foreign key. What type of relationship is it? It is strong relationship. What is the strong relationship advantage? It is going to provide addition integrity as well as it is going to provide deletion integrity such that first clear from child, then delete master. Here first add in master, then delete from child. Therefore, friends, what is your answer? As it is a strong relationship, nothing can be deleted in child, and this C1 also cannot be deleted unless and until you clear from your student relation. This is the main advantage with the strong relationship. You can protect the child data. But this, if I am writing in weak relationship, you're all guessing that 3 tuples from course and 3 tuples from other side are going to be deleted. How come it is? Let us implement. I am saying there is a course entity, course number. This is the primary key, C1, C2, and C3. This is the student entity, which is having a student number, and I am taking this course number here. So I am adding exceptions to that. Foreign key plus on update cascade. All of you observe carefully. After this session, end of the session, I will give some questions. Beautiful questions are there. You could able to solve them. You please observe, friends. Now I am posting values here. S1 joined for C1, S2 joined for same course, S3 joined for same course. Please understand. So 3 guys are joined for 3 courses. He joined for course 1, he joined for course 2, he joined for course 3. What type of relationship it is? Is it a weak relationship or a strong relationship? So if I am saying a query here, is it a strong relationship or a weak relationship? You need to decide first. Now if I am asking you, delete from course where course number is equal to C1, then how many are deleted from course? Then how many are deleted from student? How many are deleted from course and how many are deleted from student? Please give a comment. What is your answer? How many are deleted from course and how many are deleted from student? As you are saying that foreign key is exception with on update cascade. Now what will happen? How many are deleted from course and how many are deleted from student? Please observe, as you're all saying that it is a weak relationship, I'm trying to delete this tuple. Now what is going to happen? So you're all guessing that there is a one tuple from course is deleted and all the three tuples of your master will be deleted. This is your answer, right? But your answer is wrong. Please observe carefully, friend. This is the type of the twist you need to understand carefully, especially in the constraints topic. It feels that we know everything, but real-time implementation, it has hats off to constraints. You cannot able to solve it in easier manner. That's why this lecture is very much useful in order to have good kind of tips. Now you observe this is wrong and this is also what wrong. Why? Because you have mentioned only what on update cascade only. You have not mentioned on delete cascade. Observe carefully. You have mentioned only on update cascade. You have not mentioned on delete cascade. Therefore, your answer is this. You are going to get what? An error. You're going to get an error message here as there is no on delete cascade. Is it clear, all of you friends? Please observe carefully. I am trying to delete this C1, so it is having interlinks with your child table. Unless and until I specify on delete option, you cannot able to delete from master as well as child because it is only on updation. On updation means what? This is executed only at the time of updation, not at the time of deletion. Please observe carefully. As I am asking a delete, as there is no delete option here, then it is not able to respond. So it will give you error. It thinks that it is only normal foreign key. It's not at all a weak relationship. Clear, friends? Now you understand this question carefully next. I'm saying here, I'm saying here course and student. I'm talking course number as your primary key and student number, and I am bringing this course number here. This is your table which consists of columns like this. Now I have C1 here, C2 here, C3 here. This is your foreign key plus on update cascade. Observe, friends. So C1 here is S1, C1 here S2, C1 here S3. Now observe, friends. I have defined only on update option only. Therefore, it is going to execute only at the time of updation, not at the time of deletion. Now you observe carefully. When I update this C1 to C100, observe carefully. When I update this C1 to C100, then what will happen? All these three values will be affected because I am modifying it. I am updating this value from C1 to C100. Then they all become C100 here. Now I can say that whatever you modify in the master instance, they will get affected into child instance as you are saying. What is the option? Cascading option. So this is a perfectly all right because as a master is updated, then child is affected here. Okay. Now I will show you a different example with on delete now. Now please observe carefully. If I am saying that C100, then don't think that the C1 will sustain and C1 will sustain and C1 will sustain. This breaks the rules of addition integrity here. Therefore, whatever you modify, the C1 becomes a C100 and all the C1 corresponding will becomes what? C100 only. It's a very simple. If I change address in one table, then it will affect address 2 in every table. I need not go and update everywhere. Automatically it will be affected. This is what is the concept of on updation. One update done multiple times. That's the concept of on update. The option is called cascade. If I'm saying, for example, no action, the other special option called no action. What is the meaning of no action? I changed C1 to C100, but your new table is a very similar old table only. It is not going to affect to your table because you have used an option called a no action. What is the meaning of no action? Now you can modify master instance, that is not going to affect to your child instance. Now what is going to happen? It is going to break the rules of what? Addition integrity, because you have got C1, but C1 is not there in your master table because it is modified to C100, then we have a C2, then we have a C3, then it is going to modify, what I mean to say, give violation to your addition. So in this case, please observe, in this case, where I am talking a no action, it is updated only in master, but child is going to be with the same because no action is going to be taken. This is about the cascading and no action. If I am saying a set null, so what is the concept of a set null? Now you know this, the master table C1 and C2 and C3, this becomes a C100 and these values are becomes nulls here, S1, S2 and S3, because you specified that whenever something is updated in a master instance, then the child values becomes what? Nulls in this. That is the power of set null option. So now I want to implement on delete. With on delete, first I am working with cascading. So I am saying here there is a course table which consists of course number. This is the primary key. There is a student table which consists of student number, and I am bringing this as a foreign key, student course number. I am using this foreign key with an extension on delete cascade. Now what will happen? Please observe, friends. C1 and C2 and C3, C1, S1, C1, S2, C3, S3. Friends, now you observe. If I delete C1 from course, if I delete C1 from course, then dash tuples deleted from student. So now you are in a position to say the answer. Dash tuples deleted from student instance. If I am deleting this C1, so dash number of tuples are deleted from student instance. This is our query. So you can get it. So it violates. Why it violates? I have defined foreign key with an extension called on delete. I am using one of the option called cascade. It's a perfect, no violation in this. Please observe carefully. No violation in this. I have represented now the weak relationship carefully. Observe. This is the weak relationship. Why? It is executing at the time of deletion whenever the data is deleted from master. Therefore, just by doing deletion, the C1 will be deleted completely and this C1 will be deleted completely like this. Therefore, you can say that your answer is two tuples are deleted from student. This is not going to be affected because it is a different tuple which is not a common value to your C1. This is the main drawback of weak relationship. But in advantage is also, what is that? If I delete in one table, then it will be affected to all other tables. This is the concept of on delete cascade. Now you observe, instead of cascade to that example, To the same example, if I am using, instead of cascade, if I am writing set null, then what will happen? Please observe, this C1 will be deleted anyhow, C2 and C3 are there, this and this are the null values in other side, but this is be as like this. This is a set null. If I am using no action option with on delete, please observe, this is on delete set null, this is, and this is on delete no action. So when I am saying that, so C1 will be deleted and this S1 will sustain there as this C1 will sustain there, the C1 will sustain there against S1, against S2, and C3 will sustain here against S3. You got C2 and C3. So especially no action is going to break the rules of what? Addition integrity in this, because you are maintaining a C1 tuple but which is not there in your master instance because already it is deleted. So three different options. One option is on delete cascade, and the second option is on delete set null, and third option is on delete no action. Okay, so now come to our examples, how you could use the concept of cascade constraints. Let us see. You can also violate deletion integrity violation. I'm saying there is a department instance which is having department number. This is your primary key. An employee instance, I'm saying employee number, and this is your department number. I brought it. This is your foreign key. Please observe. What is the type of relationship? Is this example, please observe, is this example strong relationship or weak relationship? Observe, friends. Is this example strong relationship or weak relationship? Just I mentioned only foreign key, no exception is given, and this is your only primary key. Therefore, what will happen? If I am having some values here, so I can able to maintain like this. Now 100% it is a what? Strong relationship, because there is no exception like on delete and on update. Now you observe carefully. I have a question. A drop table DEPT, is it possible or not possible? Can I drop department table? Is it possible or not possible? Please observe carefully. Can I drop department table? Is it possible or not possible? Yeah, we say that it is not possible as there is a relationship between this and this. Clear? But this you can break. This you can break using a query I am writing. Please observe, is a very good, excellent query. So here in this case, it's not possible you are saying, because there is a child table is associated with that. It is not possible in this case. You are going to get an error. But this we can do reverse. How? I'm saying a drop table department. I want to cascade the constraint. So cascade constraints. Therefore, what is happening? Here department table is what? Successfully dropped. Please observe carefully. Here department table is a successfully dropped because you have removed the constraint between them. You have removed the constraint between them using cascade constraint. That means this link is broken. When this link is broken, department is individual table, employee is individual table. Therefore, what will happen? Department is deleted. But what about employee? employee won't be deleted. Employee will be like that only. Just we have removed the link between department and employee. Therefore, they are not having any relationship there. Department is a separate, employee is a separate table. As I have raised the query only for the department, therefore department only will be deleted. Employee will be sustained there. This is how you can use deletion integrity with the help of what? An option called cascade constraints. Okay, friends. So instead of dropping child instance, you can directly drop the master instance. That's what the concept of cascade constraint. Just we are removing the constraint. Cascading is nothing but removing only. What are you removing? Constraints we are removing. Okay. Now using this knowledge, I have posted some questions. Please observe. And I told you how you could able to implement deletion integrity. I said that weak relationship, again I am writing, please observe friends, learn this. Create a table, employee, employee number, it is a number data type, department number, number data type. I am saying foreign key to department number, that means this I am talking. References to department table of department number. Now you can say on delete any options you want, you can specify it, cascade and set null and no action, any number of options you can specify it, no problem. And you can also write on update cascade and you can use the same option. This is how your weak relationship is being implemented. Is it clear, all of you? This is how the weak relationship to be implemented. Weak relationship is in ER, we know how to represent, but we don't know how to represent in relational model. So you can use the construction of weak relationship like this in the construction of relational model. Okay, friends? Now, let us start do the questionnaire. Now you observe carefully. Please see all of you. So all these are GATE questions only. This is one of your GATE previous question. Now you answer. I want to say that student name and student age is the key. Student name and student age together is a candidate key. Observe. Student name and student age together is the candidate key. To be the key for this instance, then the value of x must not be. Value of the x must not be. What is the value? Very nice. What is the value? Already Shankar and Shankar is here. So therefore, as I want to maintain composite primary key with the student name and student age, already 19 is present. You cannot use once again because it will be duplicate. So it must not be what? A 19. So your answer is it must not be 19. Okay. So be ready for the next question. This is your next question. Observe carefully. You take some time. I will give timer also. So I have given 3 minutes time. I have given 3 minutes time. I have given. Please solve. This is one of your previous gate question. On the relationship only. What is the answer? Yeah, it is option B. So some are saying option B. What is that? One fail and two success. So let me do this. Please observe. Roll number is a primary key and department ID is a foreign key. From here to here, it's a foreign key. Now update student, set department ID is equal to null, where roll number is equal to 1. So in this place we want to place null, and in this place we want to place null. So which is a correct? So in foreign key, this is the foreign key. In foreign key you can have nulls, but in primary key you cannot have nulls. So what is going to be? So 1 is going to be fail, but 2 is going to success. Excellent. So come to next question. You please observe, there is X and Y, two columns. X is unique and Y is the foreign key to X. Y is the foreign key to X. Then which option is correct for the insertion of your data? So I'm saying here X1 null. So can I insert or not? X1 and null. You can insert. X2, X1. You can insert null X2. You can insert X4, X2. I can insert. Simple. Your answer is what? This is true. So one can be inserted fine. Okay friends. Because this value is available earlier, this value is available in master, and this value is available in master, and a unique key, nulls are allowed. And this one is a unique value. This is not a primary key. This is a unique key. Please observe. X is the unique. And what about fourth answer? Please observe. X and Y. I am checking this. X1 null. No problem. X2 null. And no problem. then null and null, no problem. X1 and X2, this is wrong. Why? Because duplication. Yeah. So which of the following cannot be inserted? So option 4, this cannot be inserted. Why? Because X1 is a what? A repeated value here. So this is possible. X1 null possible, X2 null possible, null and null possible, X4 and this possible. Next one. X1 null possible, X2 X1 possible, X4 X2 possible, X3 X1 possible. The right answer is fourth one. Next we will see this question. So here R of ABC AB together is a primary key. Please observe. AB together is your primary key. This is your 2011 GATE question, 2014 I think so. This is your primary key. A and B together forms a primary key. Now he is creating table S, which consists of A and which consists of D and which consists of E. Please observe. E is the primary key and A is the foreign key, which is referencing to this. So the statement 1, this is completely a statement. Is it valid or invalid? Is it valid or invalid? Please you observe. This primary key is called composite primary key. Please observe. This primary key is called composite primary key. But this foreign key is called as what? Simple foreign key. Therefore, you are going to get an error. Why an error? Your primary key is having a 2-column primary key and you're asking me to refer on to 2-column primary key, but your foreign key is what? Only 1 column. Therefore, this is invalid. That means your foreign key would like to be a composite, primary key also must be a composite. If your foreign key is a composite, then the other side unique key also must be composite. 1-column foreign key must be 1-column primary key. 2-column foreign key must be 2-column foreign key. So attributes must be same. That's the concept called union compatibility. In order to establish the relationship, there is a concept called union compatibility you need to follow. Same number of columns required. Next one. Answer this. So this is like this. This is the foreign key. This is a unique. This is your foreign key. How many records can be inserted? The previous answer is false. False. Now you observe carefully. How many records can be inserted into table R? As this is a foreign key, no problem. Null inserted, unique value. Unique value, null inserted. Unique value, the 3 is existed. For unique value, 10 is not existed. Therefore, you cannot insert this. 5 is unique, but as 4 is not there, then therefore, it is also cannot be inserted. Please observe, this is not possible. As 10 is not there in your master instance, and if 5 is possible because 4 is not there, then this is also cannot be inserted. As this is unique, null allowed. As this 2 is available in the master, therefore this is possible, and null is possible. So how many records cannot be inserted here? How many records cannot be inserted? This one record cannot be inserted. This two record cannot be inserted, and your answer is what? 2. Please observe carefully. As this is not inserted, then you cannot insert this also, because 4 is not there, because 4 is removed from there. It is an error. You cannot insert that. Therefore, it is also going to give you an error as 4 is not available earlier. Come to the next question. Please observe. AB is unique. This is your primary key now. And AB is a foreign key. It's a perfect composite foreign key. How many are violated? Please observe how many are violated. I have 100. So 100 is there. It's a fine. It's also fine. 2 null. Unique key nulls are allowed. So 200. We don't have. Yeah, we have 200. Therefore, it is correct. It is correct because 200 is there. 1 null. It's a fine because null is allowed. Null 600. It's possible. 400. That combination is not there here. Please observe. There is no 400 here. And null, this is possible. And null, it is possible. Unique key nulls are allowed. Null and 200, it is possible. So how many are violated? Only one is violated. This is the error. Come to next one. This is your GATE 2005 question. Please observe this and this. This is the primary key. This is a foreign key with the on delete cascade. He is saying if I delete 2 comma 4, this one, if I delete 2 comma 4, then how many tuples to be additionally deleted to preserve referential integrity? Then how many tuples to be deleted to preserve referential integrity when 2 comma 4 is deleted? It's a very simple question, but there is a good logic. So what is the logic? As this master 2 is deleted, then this 2 is deleted because I am using on delete cascade. When master deleted, child will be deleted. Therefore, phi 2 will be deleted. This is your primary key, this is your foreign key. When master 2 is deleted, its child deleted and its child also deleted. Please observe. As you are deleting 5, this is also going to be deleted. Therefore, your answer is 527295. Option C. Come to the next question. So, what is this? A is the unique key. This is unique. C is the primary key. This is the primary key. E is the foreign key to A. This is the foreign key. Now, this is the foreign key to this. This is on update cascade. Okay, now you tell me update T1 set C is equal to 110. where A is equal to 1. So update to C is equal to 1 where A is equal to 1. Exactly to this, I am changing this value to 110. Is it possible to update or not? Please observe. As C is a foreign key to this D, as C is implying your D here. So when I am updating 112, 1012, 110, so this is modified, this is modified. Because you are quite comfortable because you are using on update cascade. But what about this set T1? Update T1 set A is equal to null where A is equal to 1. So this is, please see, update T1 set A is null. So where A is equal to 1, I want to place null here. As it is a unique, you can have nulls in this. So this is a success as well as this is also success. Please observe carefully. It is not the primary key. It is a unique key only. Observe carefully. A is the unique key. So unique key can have nulls. Therefore, A is equal to null where A is equal to 1. It is a success. No. Update T1 as A is your unique key. It is not the primary key. Please observe. A is the unique key. Yeah. This is your GATE 2016. This is your GATE 2016. Observe carefully. P is the primary key. Q is the foreign key to R, like this. It is a foreign key with the on delete cascade plus on delete cascade. And on update cascade also. On update cascade. Two are there on Q. In table 2, R is your primary key and S is a foreign key that referencing P. This is your foreign key with on delete cascade plus on update cascade. Observe carefully. Now, after this representation, if you delete 8, 3 from table 2, if I delete 8, 3 from table 2, this one, then how many additional records to be deleted from T1? How many additional records to be deleted from T1? So we know whenever master is deleted, then automatically its corresponding child tuples also will be deleted. Therefore, here our master is, what is your master? Primary key column. This is your master 8. So whenever this 8 is deleted, its child is this only. So this 8 is deleted and this 8 is also deleted and this 8 is also deleted. So the answer is 3 here. Come to the next. So answer this. B is the foreign key to A. This is the foreign key on delete cascade. So when we are saying on delete cascade, he is asking if I delete this 3, 5, then how many other tuples to be deleted from your table? How many additional tuples to be deleted in order to preserve referential integrity constraint from your table. So you people are saying 3. What are 3? Let us cross check. As your master is deleting 3, this child will be deleted. As 2 is deleted, this 2 is deleted. As this 2 is deleted, this 2 is deleted. Okay friends. So the answer is option A. 3 rows deleted. Please see. When I delete this 3 will be deleted and 2 also is deleted. When from master 2 is deleted, its child 2 is deleted, its child 2 is also deleted. Okay. So additionally, how many are deleted? 1 and 2 and 3. So, no, please observe 2 comma 3, 6 comma 2, 7 comma 2, 2 comma 3, 6 comma 2 and 7 comma 2. How many additional tuples to be deleted? Now come here. So answer this. This is our last question. So answer this carefully. This is a primary key. This is your primary key. And this is your primary key as far as the given statement. S dot A is a foreign key to R dot A. This is your foreign key. With on delete set null. On delete set null. And T dot C is a foreign key, which is referencing to this using on delete cascade. Foreign key plus on delete cascade. If I delete 1 comma 100 from your R, this one, then how many other tuples to be deleted from S and T? Then how many other tuples to be deleted from S and T? So as I am deleting 1 comma 100, then what will happen? This primary key 1 is going to affect here. So this is on delete set null. This value and this value becomes nulls. They are not get to be deleted. They are just nulls only. It becomes null. As nothing is deleted here, then there is no chaining of deletion in the T table. Therefore, your answer is what? Nothing is deleted from S and nothing is deleted from your T. So your answer is in that case is a what? 0, 0. Okay friends, now you observe carefully. So option B is correct. As I am deleting 1 comma 100, this 1 is affected. This is not on delete cascade. This is on delete set null. So when on delete set null is there, this and this is becomes null. So this row is not going to be deleted. It is sustained there only. And there will not be any chaining or cascading of deletion in T. If it is on delete cascade, I agree that this will be deleted and this also will be deleted. That will show impact onto other side also. As it is null, this is very important. As it is null, it is cannot be deleted as this is on delete set null. Okay friends, so this is how you can implement strong relationship and weak relationship and using on delete cascade, on delete set null, on delete no action, on update cascade, on update set null, on update no action, as well as I also shown you a trick how to delete the master table without deleting the child table using cascade constraints option. These are all whatever I learned from Oracle Corporation. So that I have given all tricks to you. Now you're equivalent to me in proving constraints. So we will meet in the evening special class session that starts at 7 p.m. And again tomorrow there will be a session on joints. Please don't forget that tomorrow topic is also very important. Session on joints in the afternoon session YouTube, and again same in the special class solving of the problems on join. So we'll meet in the evening session, and tomorrow YouTube lecture is at the 2 p.m. only. Thank you very much.